Yeah, good evening everyone. Good evening. Let's wait a few more minutes so that all people will come. So what is today's date? Let me check what is today's date. Yesterday 5, I think today is 6. Yeah, today's date is 6th. Yeah, today's date is 6th. Yeah, let's start now. I think all the people came. So I'm starting. I'm starting now. I'm starting. This is the place where we stopped yesterday, right? This is the place where we stopped yesterday. So let me remind you one time. Let me remind you one time. So first high level language is the input to the preprocessor. It will give, right, pure high level language. So that is input to the compiler. It will produce low level language or machine language or assembly language. Right. Next one, that is the input to the assembler, which will produce relocatable low level language, a relocatable machine language, a relocatable, right, assembly language. That is the input to the linker. So linker will link all the necessary things. Right, in a particular room there are so many clothes are there, but when you are doing packing, you will take only your necessary clothes. When you are going from one city to another city, right, while doing the packing in your house, so many clothes are there, but you will take only those clothes which are associated to you, which are necessary to you. Those you will keep in the bag. That is called as a linker. Linker will link all necessary things. So linker will make all the necessary things as one. So it will keep in the bag and it will do the, right, zip and all. So which is nothing but making one, right, making one big file, which are associated. It will make it as a single file. Then afterwards loader, which will load the program from hard disk to main memory. So this is what we done yesterday. So preprocessor purpose is, right, replacing preprocessor purpose is replacing shortcuts by actual. I'm doing one more thing. So I think shortcut there, it will replace shortcut by actual. Preprocessor. It will replace shortcut by actual. So remember, preprocessor don't do any calculation. Let me write now. Preprocessor don't do any calculation. It don't do any calculation. No calculation. Preprocessor don't do any calculation. Preprocessor don't do any calculation. It don't do calculation. It will only substitute. It will only substitute. Right? Preprocessor, it don't do any calculation. It will simply do substitution. It will replace shortcut by actual. It will replace shortcut by actual. It don't do any calculation. It will only substitute. Okay, fine. This is what we discussed in the last class. We discussed. Let's come to today's class. 6/8/25. And one more thing I want to say to you. I forgot yesterday. One more thing I want to say to you. Can you see this one? Careful, everyone. Assembler, linker, loader. These two people, right? Assembler, linker, loader. If you add the linker and loader as two separate things, total 3. These 3 people normally called as cousins of compiler. These 3 people are known as cousins of compiler. No one will ask you, it is better to write, I written. These 3 people are known as cousins of compiler. Like cousin brother, like cousin sister. So like that, cousins of compiler. For compiler, they are also helping. So when you say compiler, listen, when you say compile, when you say on a particular program compile, normally compile means this only. When anyone say compile, whenever anyone say compiler means this only. It will take a high level language compiler, it will give low level language. That is the actual compilation. Compilation means that only. But remember, for user convenience, for the compilation, right? For the user convenience, when user will say compile, not only compilation, some more things also going on. Right? After compilation, whatever will happen, those are known as, right? Those are known as compile, right? Cousins of compiler. After compilation, whatever will happen, whoever these 3 people are known as cousins of compiler. Okay, that's okay. Let's come to here. Let me know if anyone having any objection before going to the actual story. Let me know if anyone having any objection. Sir, this is not okay, that is not okay. If you have any doubt, you ask me, I will help you. First, let's clarify. Any doubt is there? Before going to start the class, please let me know. First, clarify. Any doubt? I'm starting now. Any doubt? Today's class, I'm starting now. Any doubt? Everyone. Any doubt there? Let me know. Small doubt also there, let me know, so that I can go to the actual topic. Right, Mohit, no doubt? Yeah, let's start then. No doubt, let's start now. Today is 6/8/25. So I'm starting now. Everything is ready, I'm starting now. Yeah, everything is ready, I'm starting now. So please careful. Now I will talk about compilation. How compilation is going on. Because our goal is compiler. Right? How compilation is going on. See everyone. Remember compiler. Compiler is a software. So it is a program. So remember, compiler is a one function name. Which will take high-level language as input. Actually, pure high-level language, it's okay. Compiler will take high-level language as input. So remember, compiler is a software, means compiler is a program, means compiler is a one function kind of thing. So compiler is a one function which will take high-level language as input. So if you see inside almost code, if you see the inside compiler code, so you know very well that compiler, let us assume that main program name is compiler. Let us assume main program name is compiler. Inside compiler, there are some functions. Main program will call some functions. Main program will call some functions, right? So one of the function it will call lexical analyzer. Assume that right main program name is compiler. Inside compiler, right, total program is there. So they divide it into some functions. Let us assume that one of the function name is lexical analyzer. Second one is syntax analyzer. Third one is semantic analyzer. Again I am repeating, right? So let's talk about, our subject is compiler design. Let's talk about compiler design only, right? First of all, what is compiler? Compiler is a software, means program. Program means something like function. So compiler is a main program name which will take high-level language as input. Internally, it will call some functions: lexical, syntax, semantic. Fourth one, intermediate code generation. Intermediate code generation. Intermediate code generation. Fifth one, code optimization. Sixth one, target code generation. So these are the approximately 6 functions. Compiler is the main function which will take high-level language as input, which internally call so many functions, right? So lastly, if you see output, I think it is taking high level, it will give low level language. Output is low level language. It is the input. So output is low level language. This is what exactly compiler. Some people are asking, sir, why internally inside compiler functions? Why? So you know very well, compiler is a very big task because you are converting from one form to another form. Compilation is a very big task, It look like a very small task. No, it is a very big task. Approximately, I can say 1 crore lines of code. Compiler is a very big task. You may be thinking, converting high level to low level, why that much, right? I think you have to understand, converting from one language to another language, first you have to understand what is going on. If you go little deeper, you feel that it is a very difficult. So compilation, which is converting from high level to low level, it is a very complex task. But compiler is a program. Compiler is a program, means because of it's a complex task, it is a program. Approximately 1 crore lines of code is there. So 1 crore lines of code without function, there is no meaning. So that 1 crore lines of code, based on the work what it is doing, they divided those 1 crore lines of code into some function. Lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, code optimization, target code generation. They divided 1 crore lines of code, right, where that code name is called compiler. They divided 1 crore lines of code where that code name is called compiler into so many functions, right? So those are called as lexical analyzer, syntax, semantic, intermediate code generation, code optimization, target code generation. They divided into these many functions. Maybe I think if I want to say out of these 6 people, I think if I observe clearly, second one is very difficult task. Syntax analyzer is a very difficult task. In my opinion, syntax analyzer itself will take 50 lakh lines of code. Remaining maybe 10, right? 10 lakh, 10 lakh, 10 lakh like that. But second task is very complex task, which will take approximately 50 lakh lines of code. Right? A compiler is a software which is nothing but a program which will take high-level language as the input, which will produce low-level language as output. But it's a very difficult task, means it is a very big program, means 1 lakh lines of code approximately. So that 1 lakh lines of code, I cannot write without giving any name. So that 1 lakh lines of code is divided into some functions. Lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, code optimization, target code generation. They divided into some function. Okay. Now observe clearly. Everyone observe clearly. Everyone observe clearly. When our class is going on, if I want to store anything, I am storing on the board. When class is going on, if I want to store anything, I will store on the board. In the similar way, when our compilation is going on, at any point of time, if you want to store anything, you can store in one data structure that is called symbol table. While compilation is going on, if you want to store anything, you can store in one data structure that is called symbol table. Like when class going on, if I want to store something, I will store on the board. When class going on, you want to store something, you write in your notes. In the similar way, when compilation is going on, if they want to store something, they will store, that is called symbol table. Symbol table is a one data structure which will store whenever compilation in the symbol table. You can store in the symbol table. Is there any issue? Let me know. Are you facing any network issue? Bro, are you facing any network issue? Bro, are you facing any network issue? Mohit, are you facing any network issue? Ella, are you facing any network issue? Check once. Yeah, if no problem, we can proceed further. While compilation is going on, 1 lakh lines of code is running. 1 lakh lines of code is running. Compiler means 1 lakh lines of code. Compilation going means 1 lakh lines of code is running. So at that time, if you want to store anything, you can store in the symbol table. Some people are asking, sir, who will store? Is lexical analyzer can store? Of course. Syntax, yes. Semantic, yes. Everyone can store. Everyone can store. It is something like this. When the class going on, who can ask me doubt? Anyone. Ella only can ask no. Mohit only can ask no. Tarab only can ask no. Ayan only can ask no. Anyone can ask. While class going on, any student can ask me doubt. In the similar way, when compilation is going on, any function can store. In the programming terminology, these are called functions. But in the compiler terminology, these are called phases of compiler. Terminology different. When in the compiler terminology, this is called phases of compiler. In the programming terminology, this is the functions of compiler. Whenever compilation is going on, means 1 lakh lines of code is running. Then if you want to store anything, you can store in the symbol table. Sir, who can store? Out of these 6 people, anyone can store. Some students are asking, sir, code optimization not storing anything. It's okay. It is not storing, it's okay. But anyone have right. All these 6 people, anyone want to store inside the symbol table, they can store. Whether they are storing or not doesn't matter. But everyone having right. In a classroom, there are so many people are there. Every student can ask me doubt. Some people don't ask. It doesn't mean that they don't have right. Every student can ask me doubt. Some students may not ask. It doesn't mean that they don't have right of asking. They can ask. Okay, perfect. Now some students are asking, sir, while compilation is going on, these 6 people are running. At any point of time, if you want to store anything, I will store in the symbol table. We are happy. Suppose some point of time error came. What should I do? While doing lexical analyzer, if at all error came, While doing syntax analyzer, if at all error came, there is one person, that name is called error handler. Inform to him. Error handler. Just inform to him. At any point of time, any error came, inform to him. If possible, he will handle it. Any error came, please inform to him. If while doing all these 1 lakh lines of code while running, at any point of time, any problem, just inform to error handler. He will handle it. If possible, he will resolve the error. If possible, he will resolve. If not possible, he will note it down. After compilation is over, on the screen he will print. On the screen he will print, these are the problems. While compilation is going on, at any point of time, any problem, inform to error handler. Suppose error handler you inform, he got to know you are doing some mistake, he will rectify it if possible. If he felt that it is a complex task, then you don't do anything, he will just simply note down. Simply he will note down. After compilation is over, he will print on the screen. Line number 25, there is this error. Line number 60, there is this error. Like that, he will store all and he will print. So that user can take a necessary action. So remember, compilation is going on means these 6 functions are running. Lexical, syntax, semantic, intermediate code generation, code optimization, target code generation. While doing these 6 people, anywhere, any problem, inform to error handler. Anywhere you want to store in symbol table. Store in symbol table. I hope everyone is comfortable. Right? I hope everyone is comfortable. Now I will go further. So remember, high level language is the input. Low level language is the output. You can store at anything you want to store while compilation symbol table. If at all any error, you can inform to error handler. Till now also everyone is comfortable. So above one if you are comfortable, this one if you are comfortable, this also you are comfortable. Now I can proceed to clearly what lexical doing. Clearly what syntax doing. I will explain. You may not get fully because that's what the total compiler is. So I will explain all the 6 people one time. I will explain with the help of one small example. I will try to explain all these 6 people. Mostly you may not get everything, you may not get, but 50% at least you will get. Try to get as much as possible. It will give you some idea. The process what I am going to explain, how all these 6 people are going to work out. I will explain now. Try to get as much as possible. If you don't get also, no problem, because that is the chapter. See, chapter number 1, chapter number 2, chapter number 3. Like that, chapters also there. It is only introduction. Try to get as much as possible. I am giving one example. So see the example. One example I am giving. See the example. Everyone try to catch the example. Yeah, everyone try to catch the example. So there is a symbol table. As I mentioned to you, symbol table there. There is a symbol table. Everyone try to understand. There is a symbol table. At any point of time, if you want to store anything, you can store in the symbol table. Sequence number. Variable name. Variable type. Sequence number, variable name, variable type. Symbol table. Roughly I am writing. Symbol table. Symbol table. Remember, try to understand everyone. Yeah, try to understand everyone. So everything is ready. I am writing the example. Everyone catch it. Everyone catch this one. X is equal to some statement. A plus B star. X is equal to A plus B star 60. X is equal to A plus B star 60. That is the statement. And right to this statement, how the total compilation will happen, I will explain. X is equal to A plus B star 60 to the statement. How total compilation going to be happen? I will explain. You will get many doubts. Trust me. Trust me. You will get many doubts. You have a right of asking all doubts. One single doubt also there, ask in the comment section. Right? While explaining this story, many people will ask many questions. I am going to give answer for everyone. You please type in the comment section. You please type in the comment section what doubts you are getting. I am going to help every doubt. I am going to help every doubt. I am going to help. X is equal to A plus B star 60. So I am explaining. Everyone listen. So but remember, X is equal to A plus B star 60. Before this there is a declaration also. Float. If you want to use any variable, first you have to declare first. Let us assume that there is some declaration. Actually, it is not required. So see this one. First statement is not required. We need only second statement. First statement actually not required, but you know very well. You are writing any statement means you are using any variable means first they have to declare. So I declared already. That is not our goal. Declaration is not our goal. Just I want to say that X, A, B you are using means you are already declared them. But our goal is second line only. Remember, our goal is second line only. Now, important thing. Listen, important thing. Everyone try to understand. Everyone try to understand. Try to understand everyone. Try to understand everyone. So please see this. Please see everyone. Very, very interesting story going to be happen. Please try to understand everyone. Everyone try to understand. Everyone, it's going to be very difficult. If you don't listen, it's going to be very difficult. Right now, before going to start, I will ask everyone. Who can store inside symbol table? Before going to start the actual game, I'm asking one simple question to all the people. Who can store inside symbol table? Make it fast. Who can store inside symbol table? Everyone type. Before going to start the actual drama, I am asking one question. Who can store inside symbol table? Please type, don't sit idle. Before going to start actual drama, I want to ask only one question. Who can store inside symbol table? Please give answer. Anyone can store? Yeah, all people can store. All people. So don't say to me, this person only can store. Don't say to me, that person only can store. Don't say to me like this. Anyone can, all the people, all the 6 people, anyone can store inside. All the 6 people, anyone can store inside the symbol table. Inside symbol table, anyone can store. Anyone can store. Now listen. My goal is how second statement is compiling. Whenever compilation is going on, how second statement is behaving. That is only my goal. Now listen everyone. Everyone listen. So before second line, there is a first line. Even though my goal is second line, before the second line, there is a first line. Can you see this one? There is a first line. Float XAB. Remember, declaration time only you will get to know what the type of every variable. Declaration time only you will get to know what the type of every variable. Remember, by seeing declaration, see this one. By seeing declaration, right? Compiler will call. By seeing declaration, compiler will call semantic analyzer. By seeing declaration, compiler will call semantic analyzer. Compiler will ask the semantic analyzer, hello semantic analyzer, it is a declaration, means every variable having a data type, please store in the symbol table. So see this one, sequence number 1, variable name is XO, type is float. Next one, variable name is A, type is float. Remember, declaration time only I will get to know type of a variable. Declaration time only, I will get to know type of a variable. By seeing declaration, compiler will call semantic analyzer. Compiler will call semantic analyzer. It will say to semantic analyzer, hello semantic analyzer, it is a declaration. Means data types are there. Please take these data types, store in the symbol table. So 3 and B and float. Declaration time only, we will get to know data types. By seeing declaration, compiler will call the semantic analyzer. It will say to semantic analyzer, it is a declaration. Data types are there. Semantic analyzer, please take these data types, store in symbol table. Store in symbol table. I am sure you will ask many questions. Trust me, trust me, trust me, right? I am sure you are going to ask many difficult questions. I am ready for all those. I'm ready for all those. Whatever question you will ask, I will give answer. You ask me anything, I'm going to give answer. But hold a few minutes. Hold a few minutes. You will ask me many things, but hold a few minutes, I will give the answer. Remember, everyone, my goal is not first statement. My goal is not first statement. Right. So our goal is not first statement. Our goal is not first statement. Our goal is second statement only. But remember, you are using second one, means there should be a declaration. So by seeing this declaration, compiler will call semantic analyzer. You may ask that why it is calling semantic analyzer. I will help you. I will say a reason also. Compiler calling semantic analyzer. Compiler will say to semantic analyzer, hello semantic analyzer, it is a declaration. Means data types are available. So take these data types, store in the symbol table. So semantic analyzer is K, and you will see the declaration. You got to know float X A B. Oh, X is float, A is float, B is float. You will store everything in the symbol table. Okay, fine. Now see the answer. Now see the answer. Our goal is second line only. Our goal is only second line. Now everyone remember how second statement will execute by compiler. In the compiler, first person is lexical analyzer. What the lexical analyzer is? See this one. Lexical analyzer will take this statement. See, it is a high level statement. It is a high level statement. Lexical analyzer will take this high level statement. Now some people are asking, sir, what it will do, sir? Lexical analyzer will take this high level language statement. What it will do? Remember is the first phase of the compiler. Lexical analyzer is the first phase of the compiler. Don't worry anything about first line. Don't worry anything about first line. That I am not explaining anything for first line. I am not explaining anything to first line. I am not explaining anything. Just concentrate only second line. How second line is executing by compiler? Compiler first phase lexical analyzer. So high level language statement is given to lexical analyzer. High level language statement I given to lexical analyzer. Some people are asking what lexical analyzer will do, sir. What the first phase will do? What first phase will do? Let me check. Let me check in the comment section. Can everyone write? Can everyone write in the comment section? Can you help me? Can everyone write in the comment section? Some people are saying, is it only the variables that are stored? Can it store loop statements also? Exactly. I think what a nice line. Ella is asking one nice question. Ella, keep all your doubts. Keep all your whatever doubts you are getting. Post in the comment section. I am going to help you. Lastly, I will give. As of now, I cannot give. Lastly, I will give. You all people keep on write all your doubts. This is going to be very challenging task to me. This is going to be very challenging task to me. People will ask here very difficult questions. So, but I will give answers to all of your queries. You please write in the comment section. I am going to help you. I am going to help you. Now listen. Now listen, everyone. So, first phase of the compiler is lexical analyzer. Please help me. Please help me. Please help me. What will happen in the first phase? Anywhere you go. First year BTech, first class. Can you remember first year BTech, first class? What happened? Can you remember? Can you help me in the comment section? First year BTech, first class. What happened? First phase of the compiler is a lexical analyzer. First phase of the compiler is a lexical analyzer. To that I given high level language statement. Can you help me? what the lexical analyzer will do. Whatever in the BTech first year, first class, whatever you done, most probably same thing will happen. In the compiler first class also, what I done? In the compiler first class also, what I done? In the BTech first year also, first class. BTech first year, first class, what I done? What you done? Most probably same thing here. Most probably same thing here. Same thing here. So what the lexical analyzer will do is, it will just do introduction. So lexical analyzer will say that because of it's the first phase of the compiler, I cannot do any great thing, just to do introduction. So lexical analyzer will ask every person. Lexical analyzer will ask every person, right? So please, can everyone come here? Can everyone come here and introduce? Now what the right lexical analyzer asking the first person, hello first person, who are you? Then first person will say that, right? First person will say that, hello lexical analyzer, my name is X. Right? I am X. Okay. But I am a identifier, means variable name. It will say I am a identifier. Lexical analyzer is asking every person because he is the first phase of the compiler. He don't have any idea. Lexical analyzer is asking every person, right? Can you introduce yourself? Everyone is coming and introducing. So, hello X, can you say something about you? X is saying that I am a identifier. X is saying that I am a identifier. Immediately lexical analyzer will ask one thing, right? Whenever X will say that, X is introducing to lexical analyzer. What it is saying? Hello lexical analyzer, I am a X, which is the identifier, variable name. I am a identifier, variable name. Whenever X will say to lexical analyzer, I am a X identifier. When we say like that, immediately lexical analyzer will say like this one. If you are a identifier, variable name or function name, they are called as identifier. Variable name or function name, they are called identifier. X came to lexical analyzer and X is saying to lexical analyzer, I am X, so I am an identifier. Immediately lexical analyzer will say that if at all you are identifier, you should be there in the symbol table. It is indirect meaning is if at all you are a identifier, if at all you are a variable name or function name, right? So already declaration should be there. If at all you are a variable name or function name, right, definitely declaration should be there. Means you should be there in the symbol table. So are you there in the symbol table or not? He will check. Whenever X will say to lexical analyzer, hello lexical analyzer, I am X, so I am a identifier. Immediately lexical analyzer will say that if you are an identifier, you should be there in the symbol table. Yes, he is there in the symbol table. If you want, you can check. Right? Lexical analyzer will go inside the symbol table. He will check. In the second column, he will check X is there or not. Okay, X there. Yes. If at all X is identifier, immediately he will come and he will check. Is he there in the symbol table? Yes. Then he will come back and he will say, yes, you are there in the symbol table. So not only checking, right? He will give one token number also. That is, see the token number. You are an identifier. You are there in the symbol table first row. This is one token number. So what I mean to say is, lexical analyzer will divide the given sentence into some tokens. Lexical analyzer will ask every person, please come and introduce. When X is saying that I am an identifier, immediately lexical analyzer will say that if at all you are identifier, you should be there in the symbol table. Let me check. You will go and check. In the symbol table, you will check all the, right? In the second column, everyone you will check. If you are lucky, starting itself you will get. If you are unlucky, until last place you will go. So suppose isn't that symbol table contain, if at all n variables. So I think first variable to last variable you have to verify. Worst case you have to verify all variables. Best case you have to verify only first row. Means only in that column, only first row you have to verify. So anyhow, so X is came and X is said to lexical analyzer, I am an identifier. Immediately lexical will say, if you are identifier, you should be there in the symbol table. Let me check. So he will go and check. He got to know it is there. In which row it is there? First row. So he will say, you are there in the symbol table. You are an identifier. Symbol table first row you are ID, 1. This is called token number. So from today onwards, if anyone asks you what lexical analyzer will do, it will introduce everyone, which is nothing but, right? It will divide the given program into tokens. Now see the next one. See the next one. Very interesting. Very interesting. After x equal came. Remember, equal is a assignment operator. Equal is a assignment operator. Right? Equal is a assignment operator. Try to remember. Equal is a assignment operator. But remember, you don't give any token number. It is a token. You don't give any token number. You don't give any token number. Right? You got to know. Right? Next token is assignment. Next token is assignment operator. It is an assignment operator. You don't give any token number. You don't give any token number. Remember, whatever there in the symbol table, for them only token number. For other people are tokens, but number is not required. Why? What is the reason? I will explain. Don't worry. Next one. After equal is over. Next one, A. A is A. Again, identifier. If it is identifier, it should be there in the symbol table. So symbol table, you will go and you will check. A is there or not? A there. So I think now lexical analyzer got to know that is identifier in the symbol table, second row there. So token number also given. Now next one, plus. So plus. It is a addition operator. It's a binary operator because two operands are required. It's a binary addition. It is a binary addition or a binary addition, right? Binary addition operator. Binary addition operator. Binary addition operator. Or if you want, you can say addition operator. No need to make complex also. Addition operator. Addition operator. Remember. So operator, it is a token, but there is no token number. The people who are there in the symbol table, for them only token number. The people who are there in the symbol table, for them only token number. Plus is a addition operator. Plus is a addition operator. Right? Remember, for operators, there is no tokens. Identifier, there is a token number. They are there in the symbol table. Why? I will explain. Next one, I think plus also over. Next one is going to be B, which is the identifier. Next one is a B, which is the identifier. So if it is identifier, it should be there in the symbol table. Go and check. In the symbol table, go and check. When you go in the symbol table, when you go and verify, I think there is a B available. Okay, it is ID. So symbol table, third row, it is there. Symbol table, third row, it is available. B identifier, ID, 3. Okay, that is also okay. Let's go to star. It is a multiplication operator. It is a multiplication operator. It is a multiplication operator. Remember, operator is not there in the symbol table. So if it is not there, there is no token number. Why? I will say within a few minutes. 60. Remember 60. Right? 60. It is a constant. 60 is a constant, integer constant. Integer constant. Remember, identifiers only will store inside symbol table. Either a variable name or function name. They won't be stored in the symbol table. 60, it is integer constant. 60 is an integer constant. Remember, it is a constant, it don't change. So please be careful. I think until now everything is fine. So I think my final question to all the people, my final question to everyone, what lexical analyzer, understand everyone, what lexical analyzer will do? I'm expecting answer. What lexical analyzer will do? It divides the given program into tokens. Lexical analyzer purpose is dividing program into tokens. Dividing the given high-level language statement. into tokens. Into tokens. For some tokens, token number will be given. For some token, there is no token number. So if you observe clearly, how many tokens are there? Right? Lexical analyzer will divide the given program into tokens. So token 1, 2, 3, 4, 5, 6, 7. Right? Totally, I think 7 tokens. It divides the given program into tokens. It's totally 7 tokens. Totally, it's 7 tokens. Out of those 7 tokens, for 3 tokens only, token number is given. Only for identifier, token number is given. Now, from today onwards, if anyone asks you, lexical analyzer will do what? It divides the given program into tokens, which is nothing but introduction, asking every person, what are you? Hello X, what are you? Hello double equal, what are you? Hello A, what are you? It will ask every person. It is something like introduction. Remember, that's what I said to you. In the BTech first year, first class, introduction only. BTech first year, first class, introduction only. MTech first year, first class, introduction only. Everywhere, first class is introduction only. Other than introduction, in the first class, what can you do? In the movie also, first half an hour, what will be there? Introduction. Right? In the compiler class also, first class, what is their introduction? Lexical analyzer, first phase of the compiler, that is also introduction. It will ask every person, can you introduce yourself? X, I am an identifier. Assignment, I am an assignment operator. A, I am an identifier. Like that, everyone will introduce. Now, some people are asking very interesting question. Why are you storing identifiers only inside a symbol table? Why not everyone? Can anyone give the answer? Inside symbol table, why are you storing only variable names? Inside symbol table, why are you storing only variable names? Why not? Why not operators? Can anyone help me? What is the reason? You can store everyone. It's okay. You can store everyone. No objection at all. But why are you storing only variable names? Why are you storing inside symbol table variable name, function name? Why are you storing? Why don't you store everyone? Why don't you store everyone? Please let me know. Can anyone give answer? Can anyone give answer? Ella, can you guess? Why inside symbol table only variable name and function names? Why not variables? Sorry, why not operators? Why not keywords? Why not operator? Why not keywords? Why not constant? Why it is storing only identifier? Identifier means variable name, function name. Except these two, it don't store other. Yeah, that is the reason. Remember everyone. C compiler knows C language operator. C compiler knows C language keywords. C compiler knows C language constants. The only thing C compiler don't know is, right, user defined variable names, user defined function. See, user can write variable name whatever you want. User can write function name, user defined function, whatever way you want. Right? Remember, in the C language, operators are fixed. In the C language, operators are fixed. Keywords are fixed. Special symbols are fixed. The only things which are not fixed is, right, identifiers are not fixed. Some conditions are there for identifier, but they are not fixed. Try to remember. When you say C compiler knows its operator. C compiler knows its keywords. C compiler knows it's a special symbol, but C compiler don't know its variables. User can give variable name whatever way he like, whatever type he like. User can give the function name whatever way he like, whatever type he want. So only identifiers are not fixed, remaining all are fixed. That is the reason. That is the reason. That is the exact reason. That is the exact. C compiler knows. Already compiler having, yeah. Already compiler having what is plus operator, what is multiplication operator. Already C compiler knows very well. C compiler is 1 lakh lines of code. In those 1 lakh lines of code, some code contain already operator. Some code contain already keywords. When you say C compiler, which is 1 lakh lines of code, in those 1 lakh lines of code, few lines contain already operator. Already, right? Already keywords. Those 1 lakh lines of code, already operator list is there. Already keyword list is there. The only list which is not there is user defined variables, user defined functions. They don't have. So those things will be stored in the symbol table. The things which are already fixed, they are already there in the compiler. The things which are not fixed, the things which are depending upon the user, they will be there in the symbol table. Anyhow, you no need to confuse that much, right? So lexical analyzer is a first person of the compiler. He can do maximum introduction only. He can introduce everyone. It will ask everyone, hello X, so can you introduce? Identifier. Oh, are you identifier? Let me go and check in the symbol table. He will go and check. Let me go and ask in the symbol table. He will go and check. Right? He will go and check. So please be careful. Similar way, assignment operator. Assignment operator. Oh, operator. I know very well. So identifier. Oh, identifier. Let me check in the symbol table. So next one, plus operator, addition operator. I know you are my addition operator. You are there in my code also. Identifier. Oh, identifier. So let me check in the symbol table. Like that, you check. Multiplication operator. So like that, all are there. Okay, I think everything is perfect. So just remember, lexical analyzer will divide the given program into or given statement into tokens. Now see the output. See the output of the lexical analyzer. Can you see everyone? Can you see everyone? See the output of the lexical analyzer. See the output of the lexical analyzer. So lexical analyzer will take the high level language statement as input. It will produce token string. See the token string? A means ID1. It is the token. From now onwards, tokens will be forwarded. From now onwards, tokens will be forwarded. From now onwards, tokens will be forwarded. ID1 is equal to ID2 plus ID3 star 60. So remember, lexical analyzer input is high level language statement. Output is token string. Output is token string. Input is high level language statement. Output is token string. Try to understand. Output is token string. Output is token string. Remember everyone, output is a token string. So this is the output. Now listen, this is the input to. Careful everyone. This is the input to. This is the input to. Syntax analyzer. This is the input to syntax analyzer. ID1 is equal to ID2 plus ID3 star 60. Right? So this is the right output of the lexical analyzer. But this is the input to the syntax analyzer. Some people are asking what syntax analyzer will do, sir? Name itself saying syntax analyzer. Name itself saying, remember everyone. Syntax analyzer. It is a very, very important one. It is a very, very important one. Please try to understand everyone. Please try to understand everyone. Everyone try to understand. Syntax analyzer input is token string. Syntax analyzer input is token string. Careful everyone. Right. Now listen. Now listen, everyone. Now listen, everyone. Everyone have to listen. Everyone have to listen. S goes to, see this one. S goes to ID equal to E. S goes to ID equal to E. E goes to E plus T. T goes to T star F. So remember, E goes to T. T goes to F. F goes to ID. T goes to F. F goes to ID. Easily will get. Don't worry. Don't worry. Easily will get. F goes to integer constant. F goes to integer constant. Some people may be not getting, guarantee will get. I know you will get. I know you will get. So this is ID1. This is the ID1. This is ID2. This is ID3. Remember, this ID1 is, this is ID1. So see this one, first to ID1. Next to assignment. Next one, ID2. Next one, plus operator. Next one, ID3. Next one, star. Next one, this is 60. This is 60. So what I mean to say is, everyone observe. What I mean to say is, syntax analyzer input is token string. Listen, everyone now. Syntax analyzer input is token string. But output, if you observe, syntax tree. Output, if you observe, it is called syntax tree. This is a syntax tree. Output, if you observe, it is a syntax tree. Input is going to be token string. Output is going to be syntax tree. Output is going to be syntax tree. Now it is the correct time to ask you. Everyone understand. It's a correct time to ask you. Everyone give answer. What is syntax analyzer input? It's a very difficult to say. Let's check. Syntax analyzer input. Please help me. Syntax analyzer input. Everyone try. Syntax analyzer input. Bro. Syntax analyzer input. Token string. Anything else? Syntax analyzer input is token string. Output is syntax tree. That is also okay. But remember everyone. Syntax analyzer input is token string, and one more is grammar also. This is the grammar. So this is the grammar. Syntax analyzer input is going to be two things. One is token string, another one is grammar. Syntax analyzer input is two things. Token string also and grammar also. Those are the two inputs. Output is syntax tree. But I want to ask you one interesting thing. Syntax analyzer input is token string also, grammar also. Output is syntax tree. Please help me. Right? Grammar is came from where? Two things are input, okay. Syntax analyzer input is two things. String also and grammar also. Can anyone help? Grammar given by whom? Grammar given by whom? Remember everyone. Grammar is nothing but rules. Grammar is nothing but rules. Remember, rules are nothing but a compiler. That 1 lakh lines of code is grammar only. That 1 lakh lines of code is grammar only. So remember, grammar means rules. Remember, compiler is nothing but rules only. What is the compiler? Compiler is rules only. What are the rules? These are the operators. These are the keywords. Variable should have, right? This data type. Every variable should be declared. So remember, grammar means rules. Rules means compiler. Syntax analyzer, two things required: token string also and grammar also. Remember, compiler itself is grammar only. Compiler itself is grammar only. Some people are asking, sir, what is the token string? Remember, token string is nothing but program, user program. So what I mean to say is, syntax analyzer will take user program in the form of a tokens. Token string is nothing but user program. User program normally in the high level, you convert it into tokens. So syntax analyzer, two things as input. One is user program, which is nothing but a token string. One more is grammar, which is set of rules. Remember, grammar means rules. Rules means compiler. So this is the inbuilt. It is already there inside. So no need to give it. Already inside. Already exists. No need to give any input. It is already there. But remember, syntax analyzer required two things. Syntax analyzer required two things. Grammar also, string also. Grammar also, string also. Okay, string is user program, okay. But what about grammar? Grammar already there inside. Compiler is nothing but grammar only. Already inside. No need to give. Already inside. No need to give. Already inside. When you say compiler is installed, you only say C compile. Listen, C program you cannot compile without compiler. C program you cannot compile without. I'm repeating once again. C program you cannot compile without C compiler. C compiler should be there, then only you can compile C program. C compiler there means rules are there. Rules are there means, right, grammar is there. So already you have a grammar. Remember everyone, syntax analyzer required two things. User, right, string also and grammar also. Grammar is inbuilt. So you no need to give. You have to give only token string, because it is an inbuilt thing they will take. So finally it will generate syntax tree as the output. So from today onwards, if anyone asks you syntax analyzer input, you say token string, right? If you want, you can say two things as input. Token string is one input, grammar, but grammar is inbuilt. Grammar means compiler. Without compiler, you cannot compile the program. In my computer, compiler is not there. How can I compile the program? So compiler should be there first. Compiler means grammar there. Grammar should be there first. So syntax analyzer input, right? User program also and grammar also. When you say compiler is already installed, oh, compiler is already there, means grammar is already there, rules already there. So these rules and this input string, try to draw the tree. For the existing rules, the program, whatever user is written to that program, right, using the existing rules, try to draw the tree. If tree possible, let us assume that syntax tree possible. Using the existing rules, you are able to draw the syntax tree perfectly. Right, using the existing rules for the given program, I am able to draw the tree perfectly. That means syntax tree possible. That means there is no syntax error. Syntax tree possible. That means no syntax error. Suppose assume that using the existing rules for the user program, syntax tree not possible. There is a syntax error. Now there is no syntax error because the tree possible. Syntax tree possible. Let us assume that syntax tree possible. No syntax error. Suppose not possible. Syntax tree possible, no syntax error. Syntax tree not possible. Syntax tree not possible. There is a syntax error. Right? Syntax tree not possible. ST means syntax tree. Syntax tree not possible. Syntax error. Syntax tree possible. Syntax tree possible. No syntax error. So listen, using existing rules. Compiler installed means rules are already there. Using existing rules. Right? For the given program, try to draw the tree. Try to draw the tree. For the user program, try to draw the tree. Try to draw syntax tree. Suppose assume syntax tree possible. No syntax error. Not possible. There is a syntax error. Remember, can you help me now? Here who is fixed? User program fixed or rules are fixed? Here who is fixed? User program fixed or rules fixed? Here who is fixed? User program or rules? Who is fixed here? User program or rules? Rules are fixed. Rules are fixed. When you install compiler, see, without compiler installing, how can you compile the program? First you have to install. When you install inside your computer, rules are fixed. Rules I cannot change. Remember, programs I can change. Rules I cannot change. If rules are also changing, program also changing, then what you check? Something should be fixed. Something should be fixed. You fix the rules, change the program. So I written one program with the existing C rules. Tree possible are not verified. I written one C program with the existing rules. I will try to draw the tree. Tree possible, no syntax error. Tree not possible, syntax error. Remember, if anyone having small doubt also, see this one. In this tree, whatever is there, all are there in the grammar check. I am not see all the white color things are rules. All the white color things are rules. Whatever there in the grammar, those only I used. The only thing is the tree format I written. Grammar will be written, see, horizontal. Like this I written. Grammar is written in something like horizontal kind of thing. But when you say tree, vertical direction. S goes to ID is equal to E. So this one. Right? Next one. E goes to E plus T. This one. Next one. E goes to T. This one. T goes to T star F. This one. T goes to F. This one. F goes to ID. This one. F goes to integer constant. This one. So same grammar only I used in the form, right? Vertical direction I written. Remember, using existing rules, right? The program whichever you written, right, which is there in the form of a token string, try to draw the syntax tree. Syntax tree possible. Syntax tree possible. No syntax error. Syntax tree not possible. There is a syntax error. Now, last question. If anyone asks you from today onwards, syntax analyzer, what is input? Token string. What is output? Syntax tree. Then you may say that what about grammar? Of course, grammar also input. Syntax analyzer input is going to be token string and grammar also. Both are input. But one person is by default inside there. You no need to give input. He will take from inside. From user side, only program is the input. But actually, syntax analyzer require two things as input. This also. Two things as input. Output is syntax tree. But one is came from inside. People normally will ignore because it is not. We are not giving from our side. We will ignore. But actually, two things as input. Syntax analyzer input, token string, output syntax tree. I hope people got it. So remember. So syntax analyzer final output is syntax tree. Syntax analyzer final output is syntax tree. Remember one more thing. The person who will create a tree, that person name is called parser. So that is the reason it is called parse tree also. That is the reason it is called parse tree also. The person who will create that tree, that person name is called parser. Right? That is the reason it is called parse tree also. Syntax tree or parse tree. Parser able to create the tree means parse tree possible. Parse tree possible or syntax tree possible. Then there is no syntax error. Okay, I think input output is clear. Everyone observe. Everyone observe. Everyone observe. Right? Who is the first phase of the compiler? It's a very important line. Who is the first phase of the compiler? Careful, everyone. Who is first phase of the compiler? Everyone, please inform. Please inform who is the first phase of the compiler. Who is first phase of the compiler? I want answer from all. Please help me. Please help me. Who is first phase of the compiler? Lexical? Everyone give answer. Who is first phase of the compiler? Everyone I have to say. Everyone I have to say. Who is first phase of the compiler? So Mohit saying lexical. Okay. Ella also saying lexical. First phase of the compiler is lexical analyzer. See, remember, first phase of the compiler is lexical analyzer. Second phase is syntax analyzer. So some students are thinking that first phase is lexical. Lexical will do everything. No. One, right? Everything one person only doing. Then why all? First phase of the compiler is a lexical analyzer. Second is syntax analyzer. Some people are thinking that everything done by lexical. If everything done by lexical, what about other people? Why they are? Remember. Even though he is the first person, he cannot do everything. He will do only tokens. First person will do only tokens. First person will do only introduction. Because of he is the first person, everything he cannot do. Everything cannot be done by the lexical analyzer. Is the first phase of the compiler. His goal is only introduction. His goal is only introduction. First phase of the compiler is a lexical analyzer. His goal is only introduction. You don't do all. You don't do all. But the second phase is going to be syntax analyzer. His goal is syntax tree. So for every person, some task is given. I cannot do everything in the lexical. I cannot do everything in the syntax. Every person will do some task. Every person will do some task. Try to understand. Every person will do some task. Because of you are really comfortable, every person will do some task. Because of you are really comfortable. Now let's come to next one. Listen, let's come to next one. The next phase of the compiler, see this one. I am writing here. The next phase of the compiler, remember syntax tree is the input to next phase of the compiler, semantic analyzer. Next phase of the compiler is right, syntax analyzer, right? Syntax analyzer completed, we have syntax tree. That is the input to semantic analyzer. Remember, that is input to semantic analyzer. Now you will get the one more clarity. Everyone observe. S goes to ID1 equal to E. E goes to E plus T. T goes to T star F. F goes to ID. T goes to F. F goes to ID. E goes to T. T goes to F, F goes to ID, this is ID2, same thing, see, same thing I am writing. Syntax tree, same thing I am writing, don't confuse. Syntax tree, whatever you have, I am writing same thing. F goes to, careful, observe clear, F goes to integer, constant, 60. Same tree I drawn. I am not done anything, same tree I drawn. Listen, same thing. ID1 is equal to E goes to E plus T. So finally ID2, ID3 and 60. Now listen everyone. Careful, it is a very, very important one. See, whatever their whooper, see this one. Whatever syntax tree their whooper, that is the input. So semantic analyzer will take whatever tree you have, syntax tree, same tree you will take. But one question I want to ask you. Listen, one question, everyone, can everyone give answer? It's a very, very interesting one. Can you give the answer? Semantic analyzer will take syntax tree as input. Semantic analyzer will take syntax tree as input, but observe, this is the token number. Can I help you now? ID1, what is the type? Now semantic analyzer is observing. What is that one? So ID1, everyone observe. ID1 means it's identifier. If it is identifier, it should be there in the symbol table. Which row there? ID1. See, that is the advantage with the token number. If you have a token number, using this number, directly you can access. Go to the symbol table first row. ID1 is equal to ID2 plus ID3 star 60, right? So what it will do is ID1, token number ID1. So ID1, symbol table first row is there. So you will go to the symbol table by using the token number. You don't see the total table. By using token number, you will go directly, because of it is a array, random access possible, right? Using first row. You will directly go to first row. You will get to know X is a variable name, type is float. You got to know X is a variable name, type is float. So you got to know this one. To this assignment operator, left side is float is there. So remember, assignment operator, left side float. So assignment operator is expecting left side float means what is the meaning? Right side all the people should be float. So assignment operator, left side float there. He will go right side also he will check what is the type of this. ID2 symbol table, I think it is a token number. Symbol table second row he will go and he will get to know that it is a type is float. So remember this float person, right to this float is assignment operator. You are assigning something inside float. Definitely right side people should also be float. So you got to know that right side here also float there. No problem. So to do this plus operation, there are two people required, left person, right person. Left person is already float. Okay. Now to do this plus, so left over, now go to right. Once again, T goes to T star F. To do this star operation, first operand required, second operand required. If you go to the first operand, ID3, I think ID3 is a token number. Go to symbol table, third row you go. It is going to be B, right? This is also float. As he expecting, it is also float. To do the star operator, two operands required. Left operand is float. Okay. Now let's go to right. Listen, let's go to right. When you go to right, F goes to integer constant. You got to know it is not float, it is an integer. So this assignment operator is expecting, right, float. See, left hand side float is there. It is expecting float. So whenever assignment operator left side expecting float, right also all should be float. So everyone, I think a plus operator left hand side float is there. Star operator first one float is there, but star operator second one there is an integer. So he got to know that types are not matching. He is expecting float, but he got integer. So what he will do is, right? He is expecting float, but it is integer, so you will do typecasting. You will do typecasting. So remember, so it is going to be into 2 float. Into 2 float. Then what happened is this 60 becomes 60.0. This 60 becomes 60.0. Right? So previously integer constant 60, now it became 60.0. So this became 60.0. So remember, which is float. So star operator, left side is float, right side also float. It became here float. Addition operator, left side is float, right also float. It is also became float. Right, next one, assignment operator, right side is float, then left also float. So what I mean to say is, I think it is a correct time to ask you. Very, very interesting thing. It's a very, very interesting thing. I don't know how many people will give. I don't know how many people will give. Please help me. Please help me. What semantic analyzer is doing? I want answer from all of you. Please help me, everyone. What semantic analyzer is doing? Please, can anyone expect? Can anyone give answer? What semantic analyzer is doing? Just remember, semantic analyzer is doing type checking. Types are same or not. According to the programming language, one rule there. If you want to perform any operation between two people, they both should be same type. If you want to do any operation between two people, they both should be same type. They both should be same type. Try to understand. If types are not same, you cannot do. If types are not same, you cannot do. Then I have to do typecasting. So I run the typecasting. This is the way of doing typecasting. If types are not matching, you have to do typecasting. Because if you want to do any operation between two variables, both should be same type. Now, my question to all the people, right? In all the phases, which phase bothered about types? In all the phases, which phase bothered about types? Please give answer. In all the phases, which phase bothered about types? Hello? In all the phases, which phase bothered about types? Semantic goal is only type checking. So some people are asking, sir, what is this tree, sir? This is also syntax tree. This is also syntax tree. Remember, semantic analyzer output also syntax tree, but modified syntax tree. See, this is the modification. This is the modification. It's a modified syntax tree. So semantic analyzer input is syntax tree. Semantic analyzer, right? Semantic analyzer input. Semantic analyzer input, syntax tree. Output also syntax tree, but modified syntax tree. Output is modified syntax tree. See, this is called typecasting into two float. Why are you typecasting? If you want to do any operation, see, you want to do multiplication, one is float, another should also be float. If you want to perform any operation between two people, they both should be same type. If not, convert. If not, convert. Some people are asking, sir, conversion is not possible. Some people are saying, sir, sometimes conversion may be problem. If at all conversion is not possible, then it will give error message. Type mismatch error. There is error message will come. If possibility there, you will convert. If possibility there, you will do type conversion. If not possible, you will give error message saying that type mismatch error. Type mismatch error. So star operator, left side float there, right side integer there. If possible, you will try to convert the type. If possible. If not possible, you will give error message saying that type mismatch error. So remember, semantic analyzer input also syntax tree, output also syntax tree, modified syntax tree. modified syntax tree, which is also called as annotated parse tree, which is also called as annotated parse tree. Which is also called as a decorated parse tree. You may say that, sir, can't I do all these things at one time? Why you want to increase the work? Everyone having their work. Decorated parse tree. Modified syntax tree or annotated parse tree or a decorated parse tree. Suppose conversion not possible. Type mismatch error will come. Conversion not possible. Type mismatch error will come. Please careful. Type mismatch error will come. Please careful. Now observe clearly. Everyone listen. Top of the tree, bottom of the tree. Who will be done first? I want answer from all of you. Bottom of the tree, top of the tree. Who done first? Bottom of the tree, top of the tree. Who done first? Make it fast. Bottom of the tree, top of the tree. Who done first? Hello? Arey, respond, yaar. Bottom of the tree, top of the tree. Who done first? After 1 hour, you will give the answer. Arey, make it fast, yaar. Bottom of the tree, top of the tree. Who done first? So bottom will be done. Everyone know bottom will be done. Without bottom, how top can be done? So if I want to do this plus operator, left side should be done and right side should be done. Left side is this one, bottom will be done. Remember, bottom of the tree will be done first. So now see this one, bottom of the tree. See this one. See everyone now. T1 is equal to 60.0. So this is the typecasting. Typecasting done, it became 60.0. Typecasting done. That is the T1. Now see the next one. T2 is equal to, careful everyone, T2 is equal to, I think multiplication operator, left side is B. Right side is 60.0. So B into 60.T1. So B into, this is 60.0. This is done. You will go to here. So that is fine. So here T2 came. Now next one. This is T2. Now next one. From left side A came. This is T2. This is T1. This is T2. Now see the answer. Don't think much. So plus operation should be done. Plus means A. A plus T2 is equal to T3. Now this is T3. That is also okay. Next one. Lastly, X is equal to T3. Assignment will be done. This T3 will goes to X. So remember, this is called intermediate code generation. From the bottom, you have to write intermediate code generation. Every intermediate operation keep one temporary variable. Intermediate code generation. So this is the intermediate code. For intermediate code generator, input is going to be modified syntax tree. Some people ask, what is the output? Very simple. In the tree, From the bottom onwards, start writing. From the bottom onwards, start writing. Remember, to do the star operator, left required, right required. Left is B, right is 60, but here already done, typecasting, 60.0. First to 60.0 T1. Next to. So B into T 60.0, which is T2. This is T2. Next one, left side is A plus T2, which is going to be T3. Next one, lastly, X is equal to T3. So remember, intermediate code generator, input is going to be syntax tree, modified syntax tree. Output is intermediate code. Output is going to be intermediate code. Now see this one. Now see everyone. Code optimization. Now see everyone. Code optimization. Code optimization. If any chance there, optimize. If any chance is there, please optimize. Code optimization. If any chance there, optimize. Let me optimize here. See this one. Let me optimize here. T1 is equal to code optimization. Can you see this? T1 is equal to 60.0. Okay. Next one. T2 is equal to, everyone observe, A plus T1. Okay. See the next one. T2 is equal to B into T1. Okay. Next one. T2 is equal to, everyone observe, A plus T2. A plus T2 previously going to T3, right? A plus T2 previously going to T3, lastly T3 going to X. Why don't you write directly X? Why don't you write directly X? If possibility there, compress. If possibility there, compress. Why are you storing in T3? Finally, T3 going to X. Why are you doing unnecessarily? If possibility there, compress. If possibility there, compress. Now, this is the input to target code generation. This is the, right? This is the input to target code generator. This is the input to target code generator. Remember, target code means you have to write finally low level language. Target code means finally you have to write low level language. Can you see this? Target code means finally you have to write low level language. Nothing there, nothing, right? You can write also, no problem. You can write also, no problem. In the case of CO, right? Computer organization, you will write that only. Let me write major thing. What the target code generator will do is, it will scan the code, it will check. What is the answer? Oh, mul. Some multiplication he will write. Oh, addition, add. Some more statements are there. Some more statements. Maybe move. Maybe move. So like that he will do. Just corresponding things. Okay, by seeing this one, mul. By seeing this one, plus. By seeing this one, assignment. Maybe move. Like that he will do. So just he will do mapping. So remember, this is going to be, right? Low level language. Low level language is this. Equivalent statements I have to write, but anyhow not required. So that is the reason I'm not writing. You no need to bother. Target code generation. Everything will be mapped to target code. Okay, assignment is there, move. Multiplication is there, mul. Add there, right? So, right, I think the plus there, add. It is something like mul R1, R2. Maybe addition R3, R4, something. No need to bother that much. Roughly I'm writing. You no need to bother that much. You no need to add, right? You no need to bother that much. So maybe move R1, 60.0. Some roughly I written. You no need to bother. This is going to be target code generation. So all the things one time I said to you. Roughly I said to you. If I say little more deeper, you may not get it. If I go a little more deeper, you may not get it. But anyhow, chapter wise there. First chapter is lexical analyzer. Anyhow, you will see in the first chapter more clearly. Just understand the terminology. Lexical analyzer, tokens. Syntax analyzer, syntax tree. Semantic analyzer, modified syntax tree. Intermediate code generation, you will create intermediate code. Code optimization, if any possibility there, you will compress. Target code generation, you will convert high level to low level. So your assignment there, move. Multiplication there, mul. Plus there, add. So something like that you will convert. You will convert into using target code. Using target keywords, you will convert into target code. Fine. Are you okay a little bit? Are you a little bit comfortable? Bro, are you a little bit comfortable? Bro, are you a little bit comfortable? Let me know clearly here. Is it okay? All the 6 pages, are you okay? All the 6 pages, are you okay? And one more thing. Please help me. One more thing. Mostly, listen, in the symbol table, types are there or not there? In the symbol table, types there or not there? In symbol table, types there or not there? In symbol table, types there or not there? Bolo yaar. Are no response. In symbol table, types there or not there? Everyone respond. In symbol table, types there or not there? Types there. Okay, types there. But who need those types? Who is doing type checking here? Symbol table having types. Symbol table having types. But who needed types? Lexical or syntax or semantic? Who needed types? Semantic. So symbol table contain types needed by semantic analyzer. So what I mean to say is mostly inside symbol table, right? Mostly inside symbol table, the types are written by semantic analyzer. That is the reason I said to you, right? See this one. These types are needed by semantic analyzer. These types are needed by semantic analyzer. So you only should store. So by seeing declaration, see this one. By seeing declaration, semantic analyzer came and stored it. Semantic is stored. Because types associated to semantic analyzer. See, if I want types, I have to store. Semantic only will store because types associated to semantic analyzer. Careful. Now, my question to everyone, if I ask you from today onwards, who stored inside symbol table? If I ask you from today onwards, who stored inside symbol table? Can you help me? Who can store inside symbol table? All the people are not. Inside symbol table, who can store? All the people are not. So that's what I'm saying. Something related to type means semantic analyzer. Related to type means semantic analyzer. Type mismatch means type only. Type mismatch means type only. Related to type, semantic analyzer only. Can you help me? Who can store inside symbol table? All can store symbol table. Inside symbol table, all can store. Lexical also can store, syntax also, semantic also. Whether they will store or not is none of our business. Everyone can store. Everyone can take from symbol table. Everyone can store inside symbol table. Depending upon requirement, they will see. Right? If you observe clearly, token numbers are given from symbol table only. In the symbol table, first row, A is there. Sorry, in the symbol table, first row, X there. So token number is ID, 1. So who is given token number? Lexical. So everyone can use it. See, everyone can store here. Everyone can store in this. Everyone can take also from this. If anyone asks you who stored inside symbol table, types. Types needed by semantic analyzer. Semantic analyzer is stored. Semantic analyzer got to know that you need types. So wherever types are there, semantic analyzer will come into the picture. They will store inside symbol table. From today onwards, if anyone asks you who stored inside symbol table, you say all. If all is not there, I think semantic analyzer. If you observe clearly, semantic analyzer. So types are there. So types are stored by semantic analyzer. But remember, answer is all. Answer is all. If semantic is there, suppose only one. So only one selecting is actually wrong, because inside this table anyone can store. Depending upon their requirement, anyone can store. But by seeing these types, I can say these types are stored by semantic analyzer. But remember, the only expected question is who can store inside symbol table? Inside symbol table, all can store. People are misusing only one person storing. No, anyone can store inside symbol table. Inside symbol table, all pages can store. Inside symbol table, all pages of compiler can store. So this is the very, very important. Don't say semantic. If you want to select one, I think all are correct. Answer is all. Inside symbol table, all pages of compiler can store. It is no one's property. It is no one's property. All can store. If I want to say, I can say semantic also. Because the types needed by semantic, I can say. But see, in the examination point of view, what is needed, I am explaining only that part. In the examination point of view, what is needed, I am explaining only that part. By seeing that, you may be concluded that only semantic is storing. No, all people can store. So compiler book, listen, compiler book contains 1500 pages. Compiler book contains 1500 pages. If you read all the 1500 pages, you will got to know that all people are storing. Compiler contains 1500 pages. If you study all 1500 pages, you got to know that inside the symbol table, all are storing. Because of, I said, only fraction of our requirement. See, GATE syllabus contains only fraction. Because of, I said, only small story. By seeing small story, don't say that only semantic is storing. Every phase can store inside symbol table. Inside symbol table, all phases of compiler can store. Because if I said small story, by seeing small story, don't think that semantic only can store. Everyone can store. If you read these 1500 pages, you will get that idea. If you read these 1500 pages, you will get that idea that all can store. All can store. Who can store inside symbol table? All. Mostly these types are stored by whom? Semantic. Mostly. But maybe others also stored. But because everyone having right. Inside symbol table, everyone having right. By seeing these types, I can say that I can guess a little bit. Oh, okay, semantic may be stored. Semantic stored because types are associated to semantic. We can think like that, but everyone can store. Lexical also can store. Tomorrow's class, I will explain when lexical will store. Tomorrow's class, I will explain how lexical will store, because he is the first phase of the compiler. Sometimes he may also store. He is the first phase of the compiler. Maybe sometimes he will also. Remember, every person can store inside symbol table. So today's class is introduction to compiler. Just I want to give some introduction. Little bit doubts are there. Tomorrow you will get more clarity. Tomorrow you will get the more clarity. Introduction to compiler. Tomorrow you will get the more clarity. Right? This is all the 6 people will work how? All the 6 people will work how? Very simple, very simple. Lexical, dividing program into tokens. Syntax, creating syntax tree. Semantic, type checking. Semantic means type checking. Types are taken care by semantic. Type checking. Right? Semantic analyzer, type checking. Semantic analyzer will take care about type checking. How type checking? So you will see every time. You will go inside the symbol table, you will check. See, ID1, by using this token, you will go inside symbol table, you will check ID1. What the type? Float. Oh, assignment operator, left side float. Oh, right also float required. Everywhere you will go and you will ask, what is your type? Mine also float. Okay, what is your type? Mine also float. Okay, what is your type? Into. Oh, problem. Then you will try to convert. Suppose conversion not possible. Error message. Conversion possible. 60 becomes 60.0. Then afterwards multiplication. 2 floats if you multiply, you will get float. Two floats if you add, you will get float. Float will be stored in, right? So in the float only. So I think you will take care about type checking. Remember, semantic analyzer, type checking. Syntax analyzer, syntax checking. Lexical analyzer, introduction means tokens. Last 3 people are very simple. So intermediate code generation. If any chance is there, optimize. Convert this code into target code using target keywords. I think by seeing the star operator, mul is the keyword. By seeing the plus operator, add is the keyword. By seeing assignment operator, move is the keyword. So by using keywords, please convert it. So high-level language statement. Remember, this is the high-level language statement. Convert it into low level. Tomorrow I will give conclusions. Remember, it is a very, very important thing. Inside symbol table, all pages people can store. I said only small story. By listening that small story, don't conclude. One person only will store inside symbol table. No, all can store, all can take. Who can ask the question in the classroom? Every student can ask. Who can ask the question in the classroom? Everyone. Right? Everyone having right. Same thing. In symbol table, everyone can store. If you study these 1500 pages, you will get to know all people can store. Yeah, perfect class. It is a perfect class. Any doubt there? Let me know. It is a perfect class. This is the perfect class. Today's class, my goal is this. I want to complete introduction fully. So I started here. Introduction to compiler. Sixth is the today's date. Today's date is the 6th, right? Introduction to compiler. I want to complete. I think I finished it. Some conclusions are there. In the tomorrow's class, I will clarify. In tomorrow's class, I will clarify. And if anyone is not joined, if anyone is not started, I request you at least start now. If anyone is not started, at least you start now. I request everyone, at least start now. So you can use this code. I think now, I changed it to 80%. You can utilize. it will change, right? 80% discount is happening. You can utilize it. Very soon, 80% discount become 30%. Very soon, 80% discount become 30%. Please utilize. After, right? If offer is changed, if you come back and if you ask me, I am helpless. EPT 595 ARJ. Use this code, you will get the 80%. Within few days, it will going to be 30%. Only 30% or 20%. So you can utilize this. Yeah, you can take any course. You can take 6 months course, 1 year course, 2 year course, whatever you want you can take. These are our placement courses, right? You can select a placement course also. Thank you so much. See you in the next class. Thank you so much. See you in the next class. Good night. Yeah, tomorrow. Yella, tomorrow you will get the conclusions. Tomorrow you will get the conclusions. Thank you so much for asking. Thank you so much for asking. Tomorrow you will get the conclusions. Fine? Okay? Yeah, only conclusions are pending. Tomorrow I will do conclusions. Yeah, thanks everyone. Thank you so much. Bye. Bye Mohit. Bye Ella.